Dear students, in this video lecture, we are going to see about the equilibrium conditions, compatibility conditions, and the static indeterminacy value. How to find the static indeterminacy value for a given structure, simple structure, indeterminate simple structure. So, what is meant by equilibrium condition? You have studied already in engineering mechanics. The equilibrium conditions are summation of forces equal to 0 and summation of moment equal to 0. In addition to that equilibrium condition, it is very necessary to have some compatibility conditions to solve the indeterminate structures. Determinate structure, it is enough to have equilibrium conditions to get shear force and bending moment and whatever be the unknown values, unknown reactions and unknown moments, unknown shear force values. But for indeterminate structure, we can't be able to analyze the structure with available equilibrium condition. It is the basic definition of indeterminate structure. So, indeterminacy I equal to U minus E. So, it defines as unknown minus number of equilibrium equations. Number of unknowns is greater than number of equilibrium equations. Normally, we have three number of equilibrium equations. Summation of fx equal to 0, summation of fy equal to 0 and moment, summation of moment equal to 0. So, these three equations are normally used in the analysis of beams. So, we consider three number of equations. If the unknown is 4, this structure considered to be a indeterminate structure. In this condition, we need additional equation. So, the additional equation is meant by compatibility conditions. So, here we are deal with the force and moment. The compatibility conditions deal with the slope and some deflection. We can make the slope equal to 0 at some point or section and the deflection equal to 0 at some point or section. The two parts of the structure are said to be compatible in displacements if the parts remain fitted together when the structure deforms due to the applied load. It means that there is no residual displacement at the fitted section. Compatibility of displacement is a powerful concept used in the analysis of indeterminate structure with the unknown resultant forces in excess of the three equations of equilibrium. So, generally we make the conclusion that the compatibility conditions can be made for any displacement or any deflection equal to 0 at a given point. So, next we come to this slide to explain how the overall design process would be. First one, the conception, it is maybe a planning. Next one, modeling. Modeling can be done by StatPro like softwares, and analysis also can be done by the softwares like StatPro, ETABS, SAP, ANSYS. So there are many softwares available. Any one of the software should be thoroughly learned by all the students to get good placements. So analysis, modeling, then design. So design software is also available, but anyhow we have to check manually for any one of the member for the adequacy of the reinforcement because all the analysis software will overestimate the reinforcement. That is, the design may be uneconomical. So, we are the civil engineers to decide whether the reinforcement is overestimated or it is economical. It is in our hand. Next one is detailing. Detailing means the reinforcement detailing. How the reinforcement is placed in the sections. So, it will be in the drawing format. So, how many number of dia and how many number of reinforcement and the dia of the reinforcement should be estimated in a separate portion of the process. Next one, drafting, that is drawing. Finally, it is estimating total cost of the project. So, these are all the elements of overall design project. Next one, different ways of modeling of geometry. Uh, it is very basic thing, but it is very essential for a design. So we have to model of a geometry in by hand drawing. We can draw a simple plan by manual drawing, or we can use by CAD software, or many number of softwares are available. Mechanical instruments like very complicated modeling can be done through ANSYS. So the real structure, here the real structure combines of beams and columns and the slabs, and we can model this structure as a two-dimensional frame. This one is two-dimensional. This three-dimensional element is represented by a two-dimensional. Only one direction is viewed through this three dimensions. So we can model as a two-dimensional element, or it can be represented by a three-dimensional element. The top element can be modeled as a plate element. So this is a grid plate element. So these are different types of modeling. Here the overall section is modeled as a solid model. So different types of modeling is available. Here the structural idealization, otherwise called as free body diagram. Already you have studied free body diagram in engineering mechanics. So it is also a skeleton structure, because there is representation of joint here. Actually here the bolt nuts or rivets are available in this figure, but we are making as a hinge point at this joint. So it is a structural idealization of the given structure. It is merely a truss member. Next one, the stability of structure. The stability of structure is having following types: external stability and internal stability. Stability is very important for the structural design. This is related to indeterminacy also. If it is overstable, that structure can be a indeterminate one. If it is very less stable or unstable, the structure can be very much a determinate structure. So there are two possibilities. The external stability. For a structure to be externally stable, the reactive forces should be non-parallel and non-concurrent. So this point is very important. The reaction component means we have vertical reaction on the fixed support. It is parallel. So it is both are parallel. So there is no unstable. There is no stable here. Any one of the reactions should be non-parallel for the existing reactions. In this figure, if you draw the force component system, and it will connect at a point, the resultant will be connected at a point. So it is a concurrent force system. So this non-concurrent force system is not established here. It is concurrent. All the forces can meet at a point while traveling. So it is also a unstable system. If three reactions are parallel, then rigid body translation takes place. Overall, the body can move. That is called translation, rigid body translation. Overall, the body completely can translate or displace from one point to another point. So the three reactions, if the three reactions are parallel, overall translation will occur. If they are concurrent, the rigid body rotation takes place. In this case, there is a possibility of rigid body rotation. If the structure becomes unstable due to the improper arrangement of three reactions, it is known as geometrically unstable. If the structure becomes unstable due to less than three support reactions, it is called statically unstable. So we are going to see examples related to this. External stability. For any two-dimensional structure, three number of reactions, and for three-dimensional structures, six number of reactions are required to keep the structure in stable condition. All reactions should not be parallel, all reactions should not be concurrent. That is, the line of action meets at one point is called concurrent, it should not be concurrent. So in this case, all are roller support. So by nature, we can understand this support can move towards any direction, that is horizontal direction. So there is no stable at all. And also it is having a parallel reaction, because what is the property of roller? It will have one vertical reaction and it will move horizontally. So there is no resistance in horizontal direction. It is having only resistance in y direction. So in these three support systems, there will be a reaction in y direction only. There is no reaction in x direction. So it will become a rigid body translation. So it is unstable. Unstable, in this condition, it is unstable because all reactions are concurrent. So if you travel this reaction force and if you travel this horizontal force and if you travel this reaction, because it is a roller, if you view from this side, it will have a vertical reaction similar to this case. So it will move horizontally and it is having only this direction reaction force. It will all connected at a point. So this reactions will be a concurrent reaction concept. So it is not at all stable. Internal stability. An internally unstable system can change its shape without any deformation of its member. Without any deformation, it can change its shape. It can bulge or it can contract or it can extend its size. Case 1. Internal stability of beams. Internal floating hinge will make internal stability in beams. In the case of an internal hinge structure, can rotate about the hinge point and the hinge become unstable. That is, if you have a beam, the hinge point means a solid circular. Normally, it is used to make the structure determinate. A hinge, the work of a hinge is used to make a structure determinate, because in this hinge point we make a condition of moment equal to 0. What is meant by moment equal to 0? There is no resisting moment here. That is its direct meaning. The moment equal to 0. If there is no resisting moment here, the rotation will be possible. This point will rotate in all 360 degrees. So this point will make rotation in its surroundings. So this structure will become internally unstable. Case 2. Internal stability of trusses. In case of trusses, if the following conditions exist, it is classified as unstable truss. What is the condition? The member is less than 2j minus 3. Normally, M is number of members and J is number of joints present in the structure, truss structure. So if the number of member is less than 2 times the number of joint minus 3, it is called internally unstable. Normally you think that if a truss is having very less member than the required member, it is normally unstable, but this classification is coming under internally unstable, because in external stability, in the previous case, external stability all deals with the reactions only. All deals with the reaction point of view. So you have to remember the difference. All deals with the reaction point of view. In internal instability case, all the point will deal with the number of members and internal hinges. That is the property inside the member. It is not relevant to the support reaction. It is the property relevant to the member and number of members. The criteria for internal stability is for the trust members. So please note the conditions. Pin jointed plain trust, that is, if it is stable, the number of members will be greater than or equal to 2j minus 3. In jointed space stress, the number of members is greater than or equal to 3j minus 6. Rigid jointed plane frame, 3m should be greater than 3j minus 3. Rigid jointed space frame, 6m greater than or equal to 6j minus 6, where m equal to number of members and j equal to number of joints. So let us take some examples. Here, all links making concurrent reaction. So the rigid body rotation will takes place. So this structure overall is symmetric structure and it is a link element. So this is called a link element. If you draw the resultant of all this member, it will concurrent at a single point. All the element, the resultant will meet at a single point. So that will make a concurrent situation, and this rigid body will rotate in overall. So that is called an unstable condition. Next one, here these two supports are roller support. Normally, it will move towards this direction when the load is or sway is applied here. That is a horizontal sway or horizontal drift is applied along x direction. These two supports will move towards right. And note this point. This is also a roller condition, will move towards right. If the movement persists, this structure will be isolated from this structure, the right hand side structure. So normally it will create a unstable condition, geometrically unstable condition. So this right side part will move separately from the left side part. Next one, example 3. The parallel force system will be created here because of the reaction, vertical reaction and horizontal reaction. All systems are parallel, and if it makes a concurrent also, then it is geometrically unstable. Here also, all the reactions will meet concurrently, will meet at here. All the force system we can connect through a line and will meet through a single point, will make concurrent force system. And some of additional unstable structure. Because of the hinge, the moment here equal to 0, and also this support condition will move towards right side. So the left side portion will be detached from the right side portion. Hence this condition will make a unstable condition. Here the truss member, it is a truss member. Left side support simply supported, right side support roller support. So this will move towards this direction. But what about this portion? There is no diagonal member here. So the number of member is insufficient. When you check with m equal to 2j minus 3, the number of members will be insufficient. So you can directly check with the values. Next one, the structural responses. So this topic will be covered in design, up to the design point. So the structural response, first of all, we need to understand excitation, that is, what are the causes, the loads, vibrations, settlements, and these are the excitation. When it is acted upon a structure, it will create displacement, stresses and strains, some resultant forces. So this excitation is the cause, this response is the effect on the structure. So what are the loads? Gravity loads. Gravity load system will comprising of dead load, live load, gladding loads, and the elements, important elements are floor slabs, beams, columns, and joists, I sections, etc. For lateral loads, analysis of lateral load system is required for wind load analysis, seismic load analysis, structural and symmetric point of view. And the important elements are columns, shear walls, bracings and beams. So now we are going to understand the characteristics of different support conditions. Generally, you have studied what are the different types of supports, fixed support, this is called fixed support, and the hinged or pinned support. So this is hinge support, and this one is pinned support. So there is some small difference because here a hinge is placed, hinged or pinned support. Both the representation is same. Next one, roller support. Roller is here. Next one, vertical guided roller. So it means that vertical guided roller means the roller will be in vertical direction, and the horizontal guided roller support will be the series of rollers. So we can see one by one in the next slides. First one, we take fixed support characteristics. See the number of characteristics listed here. We can't say simply any one or two characteristics. Simply, the fixed support does not allow any rotation, any moment. It will create a fixity. It will create a fixity. When it creates a fixity, there will be definitely a resistance. There will be definitely a resistance. This point will not allow anything. Anything means deflection as well as slope. Because if you apply a load here, normally we are talking with the slope and deflection. So why I am starting with some distance means it is a fixed support. So there is no slope available here. The slope is also 0 and the deflection is also 0 here. So these are the points which we are going to discuss in this slide. First one, how many number of reactions? So RCY, Y direction reaction is there, X direction reaction, and the resisting moment will be there. Fixed support, all reactions, all resisting forces and the moments will be there. Next one, so this is mentioned here, that is RCX will be there, RCY will be there, and MCZ will be there. Next one, we are coming to the displacement. So it will not allow any displacement in X direction, Y direction, and in Z direction there is no rotation. So this is Y term. You can change as Y. These three characteristics is same to slope also. This is represented for Y. We can also represent it for the slope. All the direction, the slope is equal to 0 here. Okay. Next one, hinged or pinned support. Already we studied the fixed support. It resists all the horizontal, vertical and moment. If you release any one of these, it will make another types of support. Basically, it all resists horizontal, vertical forces and the moment. If you release any one of here, we will make many types of support. Here I am going to release this moment and making this moment equal to 0. That is, there is no resisting moment here. And then it will create a hinged support. And in regular case, we have RAY, RAX, but here the moment equal to 0. There is no resisting moment means it will rotate. Moment means force into distance. Normally, moment is related with the rotation, force is related with the deflection. So, if there is no moment, resisting moment, this point will rotate like this. So, we can measure a theta here. So, if the moment is 0, we can measure theta. In fixed support, there will be some resisting moment. So the theta will not be available at the support point. It will available in somewhere away from the support point. So you have to realize the difference here. So the number of reactions RAX and RAY. RAX is the reaction at joint A in X direction, RAY the reaction at joint in Y direction. The displacement in X direction at joint A is 0 because it will resisting horizontal movement at this point. So the displacement 0. Here it will resist the vertical displacement. So Y direction displacement is also 0. The rotation about Z direction at joint A is 0. Actually, the other directions, the rotations will be available. That means the rotation in Z direction 0. I can change. Generally, the rotation is not equal to 0 here. Generally, the rotation is not equal to 0. In Z direction, if you deal with three-dimensional analysis, any one of the rotation is available, we can state. Because we are representing the element in 2D, so we can make a general statement. The rotation is not 0 here. The rotation is not 0 here. Next one, roller support. Here, it is a practical example of roller support. It will move towards this direction. It will move towards this direction. So only one reaction will be available, that is vertical reaction. Already in this support, the moment is 0 because it will allow some rotation. So we can make the point, the rotation in Z direction at this point is not 0. We can make generalized statement, that is theta is not 0 at this point B, because it is having no resisting momentum. Y direction reaction will be available, but Y direction displacement is 0 because it is a resisting force is available, but X direction displacement is not equal to 0. It will move towards horizontal direction and it will give some value, that is 0.003 mm in X direction deflection. So we will have some value towards X direction displacement. Y direction displacement only 0. Next one, vertical guided roller support. So this same arrangement, previous arrangement is vertically arranged. The same property is followed here. That is one RAX will be there, and here it is resisted. In previous case, we are giving a triangular arrangement, but in vertical guided roller, we are making some fixity here, but also a roller is arranged. So we make the statement one reaction along this perpendicular direction is available and one moment is also available. So this line will represent the moment is resisting moment is available here. It will make some resistance to the moment and also it can move towards this direction. So the number of reactions RAX is resisted, reaction will be developed, moment is resisted, so moment will be available. So that what about the displacement? Where it is not 0, we have to concentrate when in the roller condition where the displacement is not 0, because all the other points it will be 0. If you take any one of the support condition, it is having vertical reaction and it is having horizontal reaction. Definitely, if the structure displays, this reaction will hold the point in the same location. So it does not allow any vertical displacement and here it does not allow any horizontal displacement. But in this roller support, it will move, so the displacement is allowed. So we have to concentrate on where the displacement is allowed. So where the displacement is allowed in Y direction, the displacement is allowed. So it is not equal to 0. All other conditions, the displacement is 0. Here the moment is actually available. Moment is available. Resisting moment is available. If the resisting moment is available means moment does not equal to 0 means definitely it will not rotate. The deflection diagram will start like this. So here theta equal to 0. So that is the statement. represented here, the theta equal to 0. Next one, in the same point of view, horizontal guided roller. So what are the movement allowed here? So I am talking about two terms. One is movement allowed, another one is movement restricted. Another way is moment allowed and the moment is 0. Here the movement is allowed in this direction. So definitely the deflection y along x is not equal to 0. It will give some value 0.0025 mm. So like that we have some value. So moment the displacement in x direction will not be 0. So we have the statement here. The displacement along x direction at point A is not equal to 0. And at top and bottom we have these lines having meaning of the moment is available here. The moment is available here. So if the moment is available, there will be a resisting moment, so it will not allow to rotate. So the slope is 0 here. Slope is 0 here. And for this point of view, it will have vertical reaction. So it will not allow to displace in this direction. So the deflection in y direction equal to 0. Next one, spring support. It is all higher end element. Normally, we will deal with the master degrees, but we have to understand to find out the indeterminacy. So the number of reaction is only one. That is, it will resist along y direction. So RAY. Displacement in y direction at joint A is 0. At this point, the displacement is 0. Next one, internal hinge. We have discussed earlier in this video. The hinge point will make the moment equal to 0 at this point. So what are the characteristics? The important characteristics is moment at C is equal to 0, and the displacement in x direction at the joint is not 0. It can move, and the displacement in y direction at the point is not 0 because there is no resisting reaction at hinge point. Only the condition is moment 0. You should remember, whenever the hinge term is introduced in your study, only condition moment is 0. Otherwise, all other not equal to 0. There will be a deflection and there will be a slope. Next one, internal roller. So it will move towards any one of the direction depending upon the loading condition, and it can't transfer the horizontal reaction. It can't transfer, that is axial thrust is equal to 0. That is the force in x direction means it is called axial thrust or horizontal reaction equal to 0. Because there is no restriction along horizontal direction. It will move along horizontal direction. So the horizontal reaction or axial thrust equal to 0. Next one, displacement in y direction at joint B may not be 0, and displacement in x direction at B may not be 0. That is, the deflection will be available. Deflection will be available along y direction. Next one, internal link. So it is a special type of characteristics. The portion BC is not a beam, it is a link element. It is a link element. We are linking AB and CD with the link element CB. So the two internal pins at B and C provided. The portion BC contains only axial load because moment at B and C is equal to 0. You can remember as a hinge point. You can remember this as a hinge point. The moment here is 0 and the moment here is 0. So the displacement in y direction at joint B and C is not 0. The deflection will not be 0. There will be a deflection along x direction. There will be a deflection along y direction. So the deflection will not be 0. The only point is the moment is 0. And the types of structure. So we are going to the next level. What are the types of structure? Two-dimensional, three-dimensional basically. We have two-dimensional and three-dimensional truss element. So here we are going to study about the truss member. So we have pin jointed plane frame, pin jointed space frame, pin jointed plane frame, and 2D and 3D. So pin jointed means hinge point. You can remember hinge. So if you are studying a truss means all the members are connected at joints. So this joint is normally considered to be a hinge joint. So wait a minute. So here I am making some correction, that is pin jointed plane frame, that is two-dimensional truss. Next one, pin jointed space frame, three-dimensional truss. Here I am going to make rigid jointed. Rigid jointed, you make that correction. Rigid jointed space frame. Pin jointed means it is connected as a pinpoint. So it is normally representing truss member. Pin jointed space frame means three-dimensional truss member. Three-dimensional truss members are called pin jointed space frame. Here, rigid jointed plane frame is not representing truss member. It is a structural plane frame or space frame. Plane frame or space frame is called pin jointed plane frame as well as rigid jointed plane frame and rigid jointed space frame. So I am going to clarify further. Pin jointed means hinge point. You note it, a hinge point. Which structure is connected with completely with hinges means truss member. Okay. So we have two-dimensional and three-dimensional truss members. So pin jointed plane frame is two-dimensional truss. Pin jointed space frame is a three-dimensional truss. In the same way, if it is rigid jointed means it is directly representing frame, and rigid jointed space frame means three-dimensional frame. Okay. And the number of equilibrium equations differs for pin jointed structures and rigid jointed structures. So the number of equilibrium equations for pin jointed plane frame, it means two-dimensional truss. We have, for example, if you have the truss like this, it is pin jointed at this point. So pin jointed means otherwise called as hinge. Pin you can remember as a hinge point. So what is the characteristics of hinge? The moment equal to 0. So here the moment equal to already 0, it is not considered at all. So the pin jointed plane frame having summation of forces in x direction 0 and summation of forces in y direction 0. And pin jointed space frame will have all three directions, the forces equal to 0. Next one, the rigid jointed plane frame, that is 2D frame. So it is all 2D frame. The number of equilibrium equation normally we have considered summation of Fi0, summation of Fx0 and summation of moment 0. Next one, rigid jointed space frame. You look this picture, it is a three-dimensional frame. We have all three forces and all three moments. That's why the number of equilibrium equations is 6. Okay, with this concept, we are going to conclude this video lecture, and further we are going to discuss about the number of releases indeterminacy calculations. Thank you.